Well, thanks for making it back to the room. I know it's always hard after lunch. Also, I wonder, I don't see it, but you need to tell me how well this thing is doing with my Austrian accent. I'll try to do better than Arnold Schwarzenegger, which is one of our famous Austrians. Actually, I used to live in Boston for a total of 8 years, and it's great to be back. 4 years ago, I moved back to Austria, where I was born and raised. But every opportunity that I get to move back to my old neighborhood, it's great. I actually used to live, I assume most of you are from Boston, right? Or at least from the area. I started, when I moved here the first time, I lived in Cambridge, then in JP, Jamaica Plain, and then in Chinatown. And I mentioned in the morning, I walked by this place many, many times, but I actually never walked into this building. It's really cool, especially the place over there where we had lunch. But today, DevSecOps by default, what have, can, and must we learn from Log4Shell? I have to admit, I am by no means a security expert, all right? But I think, as all of us have experienced, or most of us, many of us have experienced the impact that security breaches and vulnerabilities can have, I think we all need to be more aware of how bad security vulnerabilities can be for all of us, either as an individual, when our data is breached, or as somebody that is responsible for building, testing, and also running software that supports the employer that actually pays your paycheck in the end of the month. Quick show of hand, I know this was asked in the beginning of on the morning session, who was impacted by, who was actually responding to Log4Shell? All right. Are you aware, like you were like frantically waving your hand, how much time did you invest? No, you don't want to say? No? Would you have rather invested the time with friends and family? Yes, all right. Now, for those that raised their hand, did you actually go look behind the details of Log4Shell and why this was such a bad vulnerability, the technicalities of it? Yes? Yeah. Who has never looked into the details of what Log4Shell? Okay, hopefully today you will learn a couple of things from me, because in my role, as you can see here, by day, I work for a company called Dynatrace. We're also in the observability space. And security is a big topic for us because we provide our software for our customers worldwide, both on-premise and in the cloud. And security is a big concern because we're collecting a lot of data. So we felt it, our customers felt it. And in my role, I try to tell our community how to not only build better software in terms of performance, because this is actually my background, but also more secure code. During the day, I work for Dynatrace, I say. At night or whenever else I have time, I am very proud to also contribute to the CNCF project Keptn. Anybody has ever heard about Keptn before? Who's this? Yeah, one hand at least, perfect. We launched Keptn 2 years ago, and Dynatrace actually donated the project to the CNCF, the Cloud Native Computing Foundation, and earlier this year we were promoted to becoming an incubator project. Right? If you're familiar with CNCF, it goes from sandbox to incubator and then to graduated. Today's topic is though really a lot about security, but I also want to tell you what Keptn can do to help you deploy better software and more secure software faster. Now, we heard a lot today about being woken up in the middle of the night and then having to respond to incidents like Log4Shell. And I thought it was really telling. I flew in from Austria yesterday and I was supposed to stay with a friend. Unfortunately, he got sick, so I had to find a hotel room last night. And I'm not sure how it is for you, but in the morning, my alarm went off. And then I was, first of all, right, I was supposed to stay with a friend, but then I woke up in a hotel room. And the interesting thing is I had 3 clocks in my room, actually 4 clocks. And what was really interesting, you can see here, first of all, I woke up on the left. It's a little hard to read, but there was my Fitbit, 3:14 in the morning. That's when I woke up. What was interesting, there was another clock in my room that showed 7, and all of a sudden, trust. Right? Then I looked at another clock next to my bedroom, 3:28, and then I logged onto my laptop and it showed 9:15. And I felt like, sometimes I guess if you're a first responder to an incident and you get woken up at 2 o'clock in the morning and all of a sudden you're bombarded with a situation with a lot of data where you don't really know what is the right data to look at and focus on, then this is not a nice situation to be in, all right? So I hope what I can tell you and teach you today will help you to, first of all, avoid any situation where you're woken up in the middle of the night and have to respond to an uncomfortable situation. But if you have to, I also want to give you some guidance on how I think you can easier and better deal with security incidents. All right, let's get going. Every presentation at the beginning that I give to practitioners obviously also has to start with how do you sell this to your management? Why is this important that you invest into security? I have a background in software quality, so for me it was always clear that actually the fun fact is I started as a software tester on a software testing product. This is why software quality is really ingrained in my DNA. I know that bugs, the later that they are found, the more expensive they are, and as we know, security vulnerabilities are obviously also, I guess, your software is not working as specified. The later you find it, the more expensive it becomes. Therefore, we want to make sure that we are not leaving any security vulnerabilities, we're not letting it into production. It's really expensive, and hopefully this can be then easily sold to the management why you need to invest in tighter security. Now, it is expensive, that's why the security by default is important. However, security is a really hard job. I'm not sure who has a security role in your organization. I know that a couple of people, yeah. Security is not just about making sure things are secure in production. What you see here is just a snapshot of our own Dynatrace development environment. Right? The way we develop, like every classical organization, we have a development, we have a staging, we have a continuous performance environment, and we have production environments. Just our dev environments alone, as you can see here from that screenshot, 1,400 hosts, 1,100 processes, 4,000 services, and we make software delivery changes. We deliver 4 releases per day continuously every 6 hours in those environments. And it's very tough for our software and security experts to actually make sure that these lower level environments are already scanned and secure. It's a really tough job. And I know that this job is not only hard for us, but also for you. So what I would like to cover today to make your job a little bit easier and sleep better at night, my talk has 4 sections. First of all, Log4Shell, a quick recap for those of you that have not looked in behind the scenes of what Log4Shell was all about. Then I want to talk about how to detect vulnerabilities better, because I think we have different ways of detecting them. There's great tools out there. We have great vendors also out in the hallway, so you should check them out. But I want to give you some ideas on what I've learned, how to detect vulnerabilities better. Then I want to tell you what I mean with DevSecOps by default. I remember the conversation or the presentation we had in the morning from the Googlers with DevOps, DevSecOps, and then, I don't know, whatever the funny names was. DevSecOps, I think, is though a good term to have. Security has to be part of DevOps. And then at the end, I want to talk a little bit about Keptn, because with Keptn, we bring you automation that brings all of your performance testing, your observability, your security testing tools, your deployment tools together to make sure that no vulnerable code actually gets deployed into production. That's what we are contributing back to the open source world with our open source project Keptn. All right, quick recap. Log4Shell. These were some of the news sites. I guess you were probably, what's your name again? Tanya. Tanya, I guess you didn't have time to watch the news on the internet because you were firefighting all this, but the internet was on fire about 9 months ago. And there's many things, right? Obviously, for those of you that have been impacted, again, you probably had to deal with other things, but for many of us that kind of watched this from a little bit more distance, we were amazed about all of the news that came out. Just a little bit of a timeline so that you understand, because I didn't know, as I said, I'm not a security expert, but for me it was amazing. The vulnerability was detected on December 10th, and at 12:40, I think it's a nice timeline, then it was listed into the NVD, the National Vulnerability Database, a couple of hours later. Then tools were picking it up. For instance, Snook is also one of the vendors that is out there, and also Dynatrace is integrating with them and other tools as well. They then listed that vulnerability and already gave it a rating on how severe that impact is. As I mentioned, Snook is then giving this data to other tool vendors that are also in that space like Dynatrace, and we were then automatically looking at our environments and the environments of our customers that we are monitoring and observing with our solution. And then a couple of hours later, after the vulnerability was initially kind of reported, we could already report to our customers and also internally which systems were actually impacted. just a quick timeline on how this kind of unfolded on December 10th. Maybe a quick explanation. I mean, log4j is I guess, the most popular logging framework, right, in the Java space. And typically in a log4j scenario, if you're building a Java application, you may use log4j to simply just log out information about the incoming requests. As you can see here in the example, maybe your HTTP, your URL, your HTTP method, your user agent string, everything is fine, makes it to a log file. However, for some instances of log4j, depending on how you ran it, it was possible that an attacker could provide a malicious string that was, if your developers were just taking the request URLs or whatever they were logging out and just logging it out one-to-one, it actually allowed a malicious attacker to kind of sneak in code that was executed in the process that was just trying to log out this particular string. For instance, it was possible, and this was some of the exploits that were published, to load external code, to download external code, malicious code into your Java application, with this opening up a backdoor, and then with this backdoor basically opening up the world for the attacker because they were already inside your system. There's also, we will share the slides. What I want to say is there's always links to articles that I found in my research. What I also really like, there is an insecure bank example, right? It's a great demo application, quote unquote demo app on GitHub, but it's an app that really shows how the log4shell vulnerability could be exploited by, for instance, passing in a malicious string as the username. That username was then logged through log4shell, and log4shell was then actually executing that code, downloading malicious code into the app, which then opened up a backdoor where you could execute any type of comment in that context of the Java process. So I thought this was really fascinating because I also wanted to learn how is this even possible that things like this actually make it into production, and how does it actually work. So if you ever have a chance and if you want to try it out, also give a little shout out to whoever created this GitHub repository. Really cool stuff what they built here to show us and teach us what the vulnerability looked like and how it was exploited. Now, log4shell was one incident, but it really just shows, I think, a much bigger problem. Because I guess a lot of you, like Tanya, right, you are responsible probably for not only one Java application, but for a very complex system, right? You have dev, production, staging environments. You have all sorts of technology, stuff that runs on-premise and in the cloud. And the thing is, log4shell is probably not the last vulnerability we have. These are just some additional screenshots from recent vulnerabilities. On the bottom right, one that was just mentioned in June, which was in Confluence, which is also a product from Atlassian that I think many of you use. And I'm sure there's many other vulnerabilities that we don't even know about yet because they are kind of like, sitting in our software until somebody actually finds that vulnerability and exploits it. So you as security experts, you have very complex systems that you're responsible for, and a lot of bad people out there that are really just trying and wait for the next vulnerability. And that makes it really hard. So how can we detect vulnerabilities better? That's something then I tried to figure out why didn't we catch these things earlier? First of all, I think the biggest challenge is when I look at vulnerabilities and also kind of relating it back to the screenshots or my pictures that I showed you from my morning today with the different times, I was overwhelmed with data and I didn't know what was the right time. The same is true if you're opening up your, let's say, security scanning tool and it says, hey, you have 1,522 vulnerabilities. Well, good luck finding the one that is actually really the one that is most important, because you cannot fix 1,522. So again, not a security expert, but I'll try to figure out what are the current approaches. File scanning is obviously one of them. It's a very brute force attack. I actually, on my Windows laptop, I did a search on how many instances of log4j do I have lying around on my laptop. And it's a lot of them because I have a lot of apps somewhere at some point installed. But do I really have a problem? I don't really know, because I don't even know if these libraries are even loaded. I don't even know if these libraries contain that version of Log4j that are vulnerable. So while it's a good approach, it just gives you a lot of alerts, but maybe not that actionable. The next thing I believe what is a little bit better is process scanning to actually figure out which libraries are actually loaded into a process, because maybe it's just lying around somewhere in a temp directory and you made backups, but it's not actively loaded. So the next thing you want to do is look into which libraries are actually loaded. Also good, but not perfect. I think what was really nice, and this is my best known option, and you remember, I think it was Daniel Kim who had the session just before, like in the morning, he talked about OpenTelemetry and instrumentation. I think the instrumentation-based approach is really cool, because with instrumentation, whether you're using OpenTelemetry or a commercial tool that can instrument that code for you, you can say, I want to know if the vulnerable function is executed, because Log4j is a big library with maybe hundreds of thousands of functions. Now, do I need to run and fix it if the vulnerable function itself within that library is not even called? Probably not. So therefore, with instrumentation, we can figure out if vulnerable code is actually executed. There's also things, not every function, when it's called, is actually really a problem. You then, if you have instrumentation in place and you can capture method arguments and return values, you can use pattern detection to really figure out if that vulnerable function is called with malicious parameters that actually shows that there's actually an attacker in place. And now the cool thing is, and this is what distributed tracing gives you, what OpenTelemetry, as I mentioned, as Daniel mentioned earlier, what it allows you to do, you can actually look at a reverse trace, which means if you have a distributed trace that shows somebody is making a call and it ends up calling the vulnerable Log4j library function, then you can do a so-called backtrace. So you basically look at who is actually the caller. You can capture things like the IP address. And so at least you have a little bit more context about where does the attack come from, and then maybe block these IP addresses to at least kind of mitigate the impact. So I'm a big fan of instrumentation-based security detection, because it really shows you if you really have a problem, or if there's just a library lying somewhere on your file system, but that is actually never loaded, or if that vulnerable function is not loaded at all. But it goes a little bit further. I want to talk about risk analysis. And with what I mean here is, you can read it, adding dependency analysis. So if you have a situation like shown here on the left, if you have a host that is completely shut off from the internet, only internal people have access to it through a VPN, it is a problem, but it might not be your most pressing problem. On the other side, if you have a situation like this, where you have a host A that is publicly exposed to the internet, and it has a vulnerability, even though there's maybe not a critical system on it, but if some attacker gets access to that host, and that host has access to host number C with a database that contains confidential information, then the scenario on the right is much more important to tackle than the one on the left. Right? So with dependency detection, this is again what Daniel showed earlier, what's possible with distributed traces and with full stack monitoring. You can see which systems are actually exposed to the internet, who are they talking to, so you can make better assessments on which of the 1,522 vulnerabilities that I showed earlier are actually the ones you should focus on first. And Tanya, I have to come to you again because you gave me your name. So if you are ever in a situation again where you have a lot of security vulnerabilities, you want to focus on those that really matter. Right? So to sum it up, this is a bad situation because you cannot fight 1,522 vulnerabilities. I think you need to focus on the critical vulnerabilities by asking those 4 questions. First, do any of my apps, and this means off-the-shelf and custom-built, actively load vulnerable code, or do I have just potential vulnerable code lying around that is not executed? Then it's less of a problem. Do my apps actively execute vulnerable code or functions? Right? Because just loading it doesn't mean I'm actually calling it, the vulnerable function. Are those apps even an open target? That means, are these apps exposed to the internet, or are they behind a closed firewall? And are those hosts that are open connected to sensitive data entities? Because then this changes, I think, from my perspective, what is critical and what is not a critical problem. There's a lot of tools out there. I just listed a few. Again, I can encourage you take the opportunity. You're here at DevOpsDays Boston. There's a lot of vendors out there that are in the security space. I'm pretty sure I didn't list all of them. I think I missed Splunk, for instance, who is also out there. Crunch 42 is out there. I just added them, and some others that I met over the last couple of months. So existing tools already automate some of this analysis. So please really look at this and leverage these tools. Because in the end, what we want is, instead of having to deal with 1,522 vulnerabilities, focus on those that are really critical. This is something that is manageable. Make sense? Yeah? Okay, good. So this was the section of the talk where I talked about what is Log4Shell all about and how can you detect, from my perspective, security vulnerabilities better by asking the right questions. Now, the next thing is, how can we automate security to DevOps? We are at a DevOps conference. And for me, it means about being proactive and continuous, and this is why I call it DevSecOps by default. What does this mean? This means is if you have any type of artifacts, whether this is a binary or container or whatever it is, I do hope that you have some tools that are statically scanning your artifacts before they even make it into any higher level environment. So container scanning or any type of scanning tools that immediately say, hey, there's some problem and let's remove them. Now, this is great for static analysis. However, not everything can be detected in a statical way. This is why I'm a big fan of test automation. I'm a big fan of performance testing, of load testing, of functional testing, because there you actually execute your code and you can figure out if your code actually executes and loads these libraries. Loads these libraries and executes the vulnerable code. And then, analyzing it, you can then hopefully find all of the other holes that are still in there. Because also remember, static code analysis only shows you what's in that package, but as your code gets deployed, by runtime it loads new things. Therefore, it's very important to test and figure out what gets loaded as code gets executed. And hopefully, right, you find all of your holes and you fix all of them, and then you only ship artifacts into production that are safe and sound and have no vulnerabilities. However, there's a problem with this approach. Not every vulnerability is known at the time when you deploy it in production. See Log4Shell. That's why it's very important to have continuous security scanning in there. How do we do continuous security scanning? We use tools that I mentioned earlier. We look at distributed traces to figure out if a vulnerable function that was just detected and reported to the NVD, for instance, is also executed in your environment, and then react quickly. Right? Because unfortunately, things like this, I fear, will happen again. All right. Last part of my presentation, automate through tooling. And this is where Keptn comes in. I just talked a lot about security tools, how to detect vulnerabilities, which tools are out there that make it easier for you to kind of filter down the 1,522 vulnerabilities to something that you should really focus on. I also told you what I think should be done in a pipeline. Static scanners, dynamic scanners, continuous scanning in production. Now, why am I here with this Keptn shirt? What can Keptn do? What is Keptn, by the way? Keptn, and I just want to read out, Tarash is another individual I met, I think 2 years ago. He's a performance engineer at Facebook. He invited me to speak at a conference 2 years ago that he's organizing, and he then put a quote out which I thought was really nice. He said, Keptn feels like a reference implementation of Google's site reliability engineering and the site reliability workbook. That was a really cool testimonial to an open source project that we built. And I also say, remember the keynote this morning on SRE and DevOps, the two Googlers, right? They showed the SRE handbook. A lot of these practices inspired what we did with Keptn. So now, what does Keptn really do? At the heart of Keptn, Keptn uses the concept of SLOs to evaluate application and infrastructure desired state. Before I continue, who knows what an SLO is? Perfect, a service level objective. It's also part of the whole site reliability engineering practices. With an SLO, you define what is your desired state of a system. It could be performance, it could be availability, it could be security, right? So what Keptn does, and this is just a screenshot of one of our UIs, Keptn at the core has a so-called Lighthouse service. So when you install Keptn, part of the installation comes the Lighthouse service. what the Lighthouse service does, it is looking at a so-called SLO definition file that you can give it. So Keptn, in the backend, you have a Git repository that you link it to, and you can specify your SLOs, your service level objectives. And here, I'm now using my magic wand. It paid off to watch Harry Potter when I was a kid. So objectives, you can see a SLI error rate, JVM memory, number of database calls, and also security, critical security issues. So that means in this file, you can specify what indicators of your software you want Keptn to analyze for you, and what is the criteria. You can see here pass and warning criteria that you can specify. What do you expect these values to be as you're analyzing the state of a system? So this is the definition of the SLOs. Now the question is, where does the data come from? The data comes from so-called SLI providers, data providers. This could be Prometheus, this could be Snyk, this could be Falco, SonarQube, Aqua, Dynatrace, Datadog, New Relic. All of these tools can provide the data. And it's also a nice separation of concerns, what you see here. So on the top, we allow you to specify what is your expectation, what's your objective of the system's health. But independent of that, you can specify for each tool, how do you query this data? Because for instance, if you use Prometheus, you may query the number of critical security issues through a PromQL that is getting it from Falco. From a Dynatrace perspective, right, it would be a Dynatrace query language. And this is a nice separation of concerns. Whoever owns observability can specify how you query this data. And on the top right, the SLO, you specify what you expect. So what Keptn then does, Keptn is actually reaching out to these tools through an open standard that we are pushing through the CNCF to query Prometheus or Dynatrace or Datadog and New Relic. So give me this data for this environment. It's then pulling the data back and is then comparing it against your objectives. It is grading every single objective and then calculates a total score. So how does this look like in a little better overview? So you have, as you saw earlier, you can specify multiple SLIs, service level indicators, and I have a list here of response time, failure rate, login, response time, and also on the bottom, security vulnerabilities. Then the objectives. In Keptn, we allow you to specify both absolute thresholds and relative thresholds. Relative means relative to the previous release, so you can also use it for regression detection. And you can say, I'm expecting my metrics to be in this particular range. And then you can also specify an overall score, right? What is overall, when you look at all these metrics, good, like yellow and bad. So the idea is, if you have a new build that is getting pushed through the pipeline, build number 1, you can say Keptn, trigger my evaluation, and let's say Keptn reaches out to your data providers, to your monitoring tool, to your security scanning tool, and everything is green. That's great that you get the perfect score of 100. If build number 2 comes along, developer makes a commit, I'm just calling out some vendors out there, CloudBees is out there, Circle CI is out there, who else is out there, Code Deploy, Urban Deploy. I think there's a couple of tool vendors out there. When they're pushing a new build, then you can say Keptn now evaluates that environment, and in this case it seems, hey, Keptn detected the system has a performance vulnerability, and also the number of service calls of the login service kind of deteriorated. It makes more backend calls, which is not okay. Therefore, we give it a bad rating. Fast feedback to the developer. Hopefully the developer fixes it. Next Git commit, next build gets pushed. Maybe the performance problem is fixed, but as you can see now on the bottom, the developer just introduced a critical security vulnerability because maybe they updated a library, a third-party library that fixes the performance issue that was introduced in build number 2 to a version that now has a vulnerability. And therefore, we are getting again penalized. Fast feedback with the intention that fast feedback, fast fixing, back to green, everything is great. So really what we try to do with Keptn here, we're trying to bring you at the core a way to define what is your not only technical, but your performance and security desired health state of your system by looking at different indicators, just as you would do normally manually by looking at different tools. You're looking at your logs, you're looking at your security scans, you're looking at the performance data, and then you say, good, so la la, or not good. We automate that, and we provide the definition of this as code. Now, this is at the core of Keptn. But there's a bigger picture, what we actually want to do with Keptn, and I just want to plant this in your mind because maybe this is something that will help you as well as you're building maybe the next platform, as you're trying to figure out how can you deploy better, faster in the future. So the big picture is Keptn is not only giving you the opportunity to evaluate SLOs when you trigger it, but Keptn really takes the SLO at the center to always evaluate the desired state of your system. Are you green or not? It gets triggered through events such as a GitOps change request or production alerts. So when you have a new change and you deploy something, let's say you use Argo or Jenkins or CloudBees or whatever it is, then Keptn can evaluate the situation and either stop the build there or not. Or if you have a production alert, Keptn can look at the observability data and collect additional information about what's happening in production right now. What are the security incidents that are actually relevant? Keptn then orchestrates processes, so we call them automation sequences. That means when a new build comes in or when a production alert comes in, Keptn is looking at the SLOs, is assessing the situation, and is then triggering other tools to figure out what to do next. For deployment, it would be assessing the situation, then deploying, testing, and validating, and you can see it in a loop. And on the bottom right side, it would be Keptn can orchestrate the remediation of problems in production. Keptn itself, however, doesn't do all the work. Keptn connects to your existing DevOps tools. And we're doing this through another open event standard. It's called Cloud Events. And we're currently standardizing not only Cloud Events, but also they're called CD events through the CNCF. Because another problem that we want to solve, besides kind of giving you a nice overview of your health by looking at different observability data, we want to solve another big challenge, which is, I'm sure most of you have different tools in your tool belt. Maybe you have multiple testing tools, multiple delivery tools, multiple monitoring tools. That means you need to build a lot of custom coding to actually call tool A and then passing the result to tool B and so on and so forth. Because every tool, even though they do the same thing or similar things, they have their own proprietary API. We are currently standardizing kind of the API of how all the DevOps tools communicate with each other. Because we should no longer build point-to-point and tool-to-tool integrations the 5th time, the 10th time over. So SLOs really drive everything that Keptn does. In the end, it's like an operator in Kubernetes. Right? The operator in Kubernetes always tries to make sure that your technical desired state, as you specified it in Git, is actually what gets deployed. What we are doing, we're raising it a level up, and we say your desired state should not necessarily be that you need 5 pods or 5 instances of a particular service. Your desired state is that your system is healthy and it is secure. And if it's not within that green range, then you want to take action and bring it back to the desired state. That's what Keptn is doing. All right, so to wrap it up, Keptn can do a lot of things, but most people that start with Keptn, they really integrate it in their existing tools with the SLO evaluation. So maybe if you're interested in this, if you think this could help you, check it out. That means define a list of indicators, SLIs, that can come from any observability tool or from your security scanning tools, and then integrate it into your existing tools as part of a delivery pipeline, for instance. Right? More information on the Keptn website, and there's tons of videos. So now to really wrap it up, I actually forgot that I had a slide that is called to wrap it up. By the way, how is my Austrian accent doing over there? Is it good? Yeah. Very good. Okay, so what have we learned today? First of all, unfortunately, the internet will be on fire again. I fear it's just happening, right? It's not going to be the last time that something like Log4Shell hit us. Tanya, especially to you and everybody else out there, don't drown. Don't drown in meaningless security alerts. Start asking those 4 questions that I raised earlier. Is the code really loaded? Is the vulnerable function loaded? What else did we have? Is the system even exposed to the internet? And does the system have access to sensitive data? These are the things that then, I think, define if it's critical or not. Think about how you can add security checks into your pipeline, but not only static scans and dynamic scans in testing, but continuously in production. And then think about, have a look at Keptn and help us drive this open source project further. If anybody is anybody going to KubeCon in Detroit by any chance in October? Yeah, we have a Keptn Community Day on Tuesday. If you are interested, we will meet. We have the community coming in, they share the experiences, and also we're going to define kind of the future of Keptn now as we're moving forward, and we are interested in hearing feedback. Good. With this, I hope I'm kind of on time. Yes. And I want to say thank you, and now enjoy the best part of the conference, which is the open spaces. Thank you.